Hello, welcome to this video where for Art 148 at Highline College, it's the review for quiz number 1. All the materials that are in this review are also available on Canvas. There's a PDF document of this exact presentation to review at your leisure. Just a reminder about the quiz. There's no notes in the quiz, no phones or other resources. All the knowledge for the quiz taking will come from inside your head. So good luck. Here we go with the review. So we're going to start where we started the quarter with exposure. And exposure is the process, as you can see here, of managing light in our cameras using 3 controls. And those 3 controls are shutter speed, aperture, and ISO. And I'm going to go through in detail about each one of these. Important thing to remember about each of these elements is all 3 of them will make your photos brighter or darker. They have the ability to do that. As they're doing that, each one also affects another property in your photo. So that's also important to be aware of. So we'll start with shutter speed. And shutter speed is the duration of light. How long after you click the shutter does the light interact with your camera sensor? Usually we're talking about fractions of a second. What changes as you change that duration of light is the appearance of motion in the photo. Longer speeds will have more motion because things moved more. Longer duration of time will get more motion in the photo. And related to that then is something to be aware of is when your shutter speeds get longer duration, when as you look at a fraction, that bottom number gets smaller, gets closer to 1, then you're probably going to have photos which aren't sharp because the photo is blurry because the camera moved during the exposure. So be aware of that. Everybody's a little different. Every camera lens combination will work a little differently on what the magic number is for that shutter speed to be aware of. As I've gotten older, that shutter speed has gotten faster that I need to pay attention to. So I used to be fine at about 1/30th of a second, but now I really need to stay above 1/100th of a second most of the time. So let's demonstrate, show what some sample photos of motion being captured in using shutter speed. So this photo is taken at 1/60th of a second. The car is going approximately 40 miles an hour. And the goal in the sequence, what I want to do is make the car look like it's not moving at all. So in order to do that with an object that's going about 40 miles an hour, that magic number works out to about 1/1000th of a second. So that way the subject doesn't look like it's moving. Everything's sharp from a motion standpoint. And next, I'm going to show you an example of unintentional motion that happens in photos with lower light with longer duration shutter speeds. So the numbers on this display are blurry just a little bit, but that's not intentional, and it's also something we can't fix with software. So we can take a photo that's a little too bright or a little too dark and potentially fix the exposure or address it, make it more close to what we want it to be, but we cannot fix blurriness like this. But intentional blur is okay and sometimes part of the story of your photo. So this is 13 seconds. The camera's on a tripod, so the camera's not moving. But the lights that are moving create these awesome trails, very interesting. The light on the left is sure moving a lot, and the Ferris wheel becomes just this kind of pinwheel of light. So that's okay. But like all things with photography or creativity, you want to be intentional, be on purpose, and make sure you understand how shutter speed and time affects the appearance of motion in your photo. Our second element of exposure is aperture, and that's the volume of light. If you could put light in a bucket and throw it on your image, how big is that bucket, that container of light? Very small or very large? And aperture affects what's called depth of field, what's in focus in the photo. And the aperture is determined, the aperture is the size of the opening in the lens. Cameras, most lenses will have variable apertures. They can get larger and smaller. And as they change that size, they're letting in a smaller opening, lets in less light. A larger opening lets in more light. But the other thing that changes as you change the size of that opening is how much of the image is in focus. So for example, with a smaller aperture number, which are also called f-stops, you'll get more light, but I'll have less in focus, a shallower depth of field. You can also switch that around. So a larger aperture number, will have less light, but have more in focus. Confusing, I know. Try to remember that the smaller numbers let in lots of light and you get less in focus. Especially in a portrait class, we kind of like that. So let's take a look at how the numbers work. Here is a very small number for aperture, 1.4, which is a very large opening. And you get this very, very blurry image once you get past the first one, or especially even the first two Lego figures here. So they get very, very out of focus. The background is just color and light and a little bit of texture, no detail. Whereas if you go the other way, all the way to f16, which is a very large opening, large number, small opening, you get much more in focus. Background's still blurry here. But all of the figures here are in focus and sharp. So storytelling, what's in focus, what's not in focus, what to pay attention to, what not to pay attention to, that's accomplished with aperture. Our third and final element in the exposure is ISO. And ISO is the electronic amplification of light. It's a circuitry inside your camera that will make your photos brighter or darker, and the trade-off as you turn the amplifier up is you reduce image quality. You get noise. You lose detail. You get elements added. Sometimes there's color shifts. It's just not it's not like the original. It's added some more stuff. And as far as how to understand how ISO is going to work on your camera, the best tip I have is to just try it. Turn your camera to the highest ISO and see how it goes. Newer cameras will let you go to higher ISO numbers and still retain pretty acceptable image quality. Older cameras, they're not as good at that. So there you go. ISO numbers are easy to understand. The smaller numbers have less light in the image, but they'll have higher image quality. So here's ISO 100. Everything's nice and sharp and nothing there that wasn't in the original photo. And then you go all the way to 25,600, a much higher ISO number. Now you can see the noise. So we've got spots of color that aren't there. We've got lack of detail. Everything's not as sharp. This is fixable though, or at least reducible. So Lightroom can reduce this, make it less apparent. The trade-off is when I took it at this high ISO, I got a much faster shutter speed. So I probably have a sharper image, which is, if I have a blurry image, something I can't fix with Lightroom. Trade-offs. Welcome to photography. All right, so that's exposure. And then once we've got exposure, our next topic we can talk about is potentially compensating that exposure, changing your mind about how bright or how dark the image is versus what the camera automatically wants to do. So if you're in an automatic exposure mode, you have the ability to do this exposure compensation. And the way you do that, most cameras will have a plus minus button on them somewhere. Sometimes it's on the top, sometimes it's around the back. And you'll hold that button down and then generally turn another dial. And if you're not sure how to do this, look in your instruction book. And if you don't have the instruction book, go to Google or your favorite search engine and plug in your camera name and exposure compensation, and it will probably come up with little tips on how to do that. All right, so once you've held this down and then you're turning the wheel, one direction will make your photo brighter. +1, +2, +3 is usually the limit. Sometimes they'll go to 4 or 5. Or you go darker, -1, -2, -3, and so on. So that's how that works. And how do you decide to go brighter or darker, or how bright or how dark to go? Just like all things in art, you just got to try it. If you're not sure, take a few photos that are darker. One that's a little darker, medium darker, and a lot darker. And then maybe 3 that are brighter. One that's a little brighter, medium brighter, lots brighter, plus the one the camera wants to do. The nice thing about exposure compensation is you don't have to really do any math. The math will be taken care of for you by the camera, so you don't have to remember how the aperture stops go up and down, and if 1/25 of a second is faster or slower than 250, the camera will help take care of that, which is awesome. Let you focus then on the composition. So here's an example of exposure compensation. The top image is at 0, so that's called 0 EV, exposure value. That's what the camera thinks is the correct exposure combination. The shutter speed is 1/25 of a second. The aperture is f16, and the ISO is 200. So in the middle image, we're at +1. So we have one more stop of light. We're brighter. Shutter speed and ISO stay the same in all 3 of these, and the one change is aperture. So the aperture in the middle one is a smaller number, which is a larger opening, which is more light. The bottom one is -1. So 22 is a larger number, so it is a smaller opening, less light. If you have to try and do that when you're first doing this, it can be really hard to remember, is 22 more or less light than 16? I've struggled with that for a long, long time, so I used this method for quite a long time, and I highly, highly recommend it. The math is not a factor now, so that's awesome. All right, moving on a little bit to not just how much light we have, but some of the other properties of light. And one of those other properties of light is white balance, which is the color of light, where we adjust the settings for the color of light available in the image we're taking. Light on a cloudless day at noon has a different color than a cloudy day at noon. Or sunrise light has different color than noon light. So there's lots of different ways that light changes in color, and that changes story. So it's important to be aware of, and it affects the overall color of light in our image as we're changing that. So if you've ever had an image that was too much of one color, it's generally going to either be too blue or too orange, either a little or a lot. That's usually a white balance issue. And that's something we can fix with software or adjust to taste using Lightroom. And white balance is a temperature. And the temperature scale we use to measure it is the Kelvin scale. The Kelvin scale. So, for example, when the cloudy white balance is 6,500 degrees Kelvin, and that is warmer. It's a warmer light. If you're lower numbers, the light is cooler, more blue. Here's another example on the low end. Well, excuse me, let me go back to this a minute. These should be in different order, I apologize. On the left, I've adjusted it to 6,500 with software, which makes it warmer. So let's go back to this slide. Here on the left are the warm tones. So it's a little confusing. Look at the bottom of this screen and you'll see how the warm tones are on the right, the reds and the oranges, and the blue is on the left. And that's because in Lightroom, that's how the chart looks. It's orange on the right, red on the right, and blue on the left because we're correcting for the incorrect exposure. So warmer light on the left, middle here is cooler light. Again, these are fixable things. Even if you're very, very blue or very, very orange and it's not supposed to be, we can adjust that using Lightroom or other software. We're going to use Lightroom. All right. So that's white balance. And white balance is important to pay attention to. The color of light in your image because it's part of your story. Warmer images, I'll go back here. The photo on the far left with the warmer tones in it really matches her smile. The middle one is kind of quiet. The bluer light is quieter, cooler, maybe a little sadder. And then the far right, that tungsten is just wrong. It doesn't match her smile. Cinema uses this quite a bit for mood and tone and atmosphere. Color grading, it's called in movies. So we can do that as well on our photos. All right, moving on to image file formats. Some information about how our cameras can save images and the advantages and disadvantages of the two major file formats in our digital cameras. So the first file format is one you've probably heard of. It's called JPEG. JPEG is the most common. It's great for sharing photos and files. It's fast. It looks good out of camera generally. You can send a JPEG to anybody and they can open it. They're fast to work with. They take up less space on your camera and on your computer. So good stuff. Some of the downsides to JPEG are relatively technical, but they're there. In order to make the file smaller, JPEG uses a process called lossy compression, which means it throws out some data every time a JPEG is saved. And there's so you can potentially lose some image quality. Most of the time, it's not a factor anymore because we use high quality settings as memory has gotten less expensive. So we don't have to reduce the image quality to get the files to fit. Also technical, we have a little bit less options when we need to edit exposure. There's less data saved, so there's less chance to correct exposure problems when you're on the very bright or very dark end. So be aware of that. Not usually an issue for a lot of the time, but something to pay attention to. If you're taking JPEGs and you're wondering why I can't get the photos to look the way I want it to in exposure, it might be because of the limit of JPEG. Again, JPEGs are great for sharing, a great place to start with your images as far as the file format to save. A little bit less work involved, but you also have less options of what you could do in the end. Here's an example of that compression artifacts you get from the lossy compression. This is exaggerated, but it shows you what's happening. You get these all sorts of shifts that happen in JPEG noise. It's more digital versus ISO noise, which tends to be a little more organic feeling. It's random but uniform. This is just random. Look at around the O near the bottom of the screen where the O curves and you have that high contrast change. There's lots of little buggy, squiggly things that don't look very natural. You got bands of lines and shifts of color. We've got some green at the lower part of the E. By the I, on the left of that, there's a little bit of purple. It's a vertical column. It's weird. So that's JPEG noise. In the worst extreme exaggerated case, you'll probably never see it like this, but it's there, smaller. Our second file format is called RAW. R-A-W, the letters RAW don't stand for anything. It's just a description of what this is, which is a digital negative. It's basically exactly the data that was captured by the camera sensor. So does not have anything added to it, no saturation, no sharpness, it's very flat when it comes out of the camera. More data is captured, which means we have more options to edit the photos, the color, and exposure. So if you want the best capture format that'll give you the most options when you get to the computer, RAW is the way to go. The downside to RAW is when you're going to need more time. Everything's a little slower because the files are bigger. You have to work on a RAW file. If you take a RAW file and put it on a camera, on a computer screen, it's going to need probably some color adjustments, some exposure adjustments, generally just need some seasoning added to it. Just right out of camera, they look very, very flat and not impressive at all. The other thing that's they take up more space, as I mentioned, which means your computer's going to work harder too. And RAW files are not universally compatible. You really won't share a RAW ever. They're not designed for that. If you've edited a RAW file, you can't share that without including the edit information, because RAWs can't contain edit. It's complicated. Don't worry about that. But anyway, RAW files are the better preferred file format when you want the most options when you edit. JPEGs, when you need to share, it'll be a JPEG. So I'm gonna show you how to convert these RAW files to JPEGs using Lightroom so that you can post them online or send them in an email. So that's how the workflow works. We'll generally start in RAW, and then when we share it with anybody online, Instagram, anywhere, or email, it's a JPEG, or even printing. So that's the differences, JPEG and RAW. When we're talking about light and we want to measure the light in our photo and understand how much of brights and darks we have, there's a tool called the histogram for that. And here's what a histogram is. It's a simple graph of the distribution of the tones in your image, which means it's a chart, it's data, it's numbers, it's helpful when you want to avoid particular problems, but it's not going to tell you if your photo's good or bad. It's information about exposure. And here's what it looks like. The photo on the left, well, let me tell you how to read a histogram. On the left-hand side at 0 value is pure black. The sensor captured no light. If you go all the way to the far right-hand side at 255, that means it's pure white. The camera the sensor soaked up all the light it could, and it can't hold any more. In between, you have those shades of gray then, which gives us colors and tones. So the image, the graph on the left with the data higher up on the chart on the right-hand side means it's a bright photo. There's lots of data in the white. There's lots of bright tones. And all the way on the far left, there's actually nothing. If you go to the graph on the right-hand side of this slide, you'll see that there's more information in the dark tone. So that's going to be a darker image. Here's another example. So a histogram with stuff on the left is going to be primarily dark, might be underexposed. A correct exposure generally is got data a lot in the middle, and it's not missing anything in the brights or darks. And you go to the far right, that's where things get brighter. So again, this doesn't tell you which photo to use. It tells you about brightness levels. It tells you maybe a mood, if there's technical issues of pure black or pure white. But again, it's not going to tell you whether to use the photo or not. But it's helpful information. Moving on, more conversation about light. Let's talk about ambient light, which is the light that's already there when you show up to take a photo. If you walk into our classroom, for example, the overhead lights are on, maybe a little bit of light coming in through the door. There's light coming from the computer screens, light reflected from the ceilings, bouncing off the walls. So that's the ambient light that's already there. If you go outside and whatever light is there, if it's a cloudy day, you got one kind of light. If you've got sunset, you've got another kind of light. So light is a huge part of our storytelling ability with photos. And especially with people, you want to pay attention to the light because it's going to change the way they look. And that comes to the next slide, which is the quality of the light can change depending on the size of the light source. For most people, not all the time, but a lot of the times, you generally want softer light, which gets you softer shadows. And the way you do that is by changing the size of your light source. And a bigger light source will give you softer light on your subject. How do you change the size of your light source? We use things called light modifiers. We take a relatively small light and then you pass it through another box generally, or an umbrella, and then it becomes larger and it's diffused and it's softer. Think about going outside on a sunny day with no clouds, and the shadows that you'll get are very hard. They have a hard and defined edge. Whereas you go outside on a cloudy day, the shadows are still there, but they have a softer edge. So next slide will show a little bit more about that. So on the left is an image taken with a very large light source, a 7-foot light source. It's basically a small light bulb going through this box, which has a 7-foot diffuser on the front. So you can see the shadows are very, very soft. You can kind of see where they end, but they're very, very soft and feathered. The light kind of wraps around your subject. So look at her hair on the left. It's got more detail in it because the light's filling it. Along her cheek and jaw, the light is softer there, so she looks a little lighter. On the right-hand side, you've got shadows that have a hard edge. Looks like they were almost drawn on. Her ear kind of disappears on that side as well. So two different stories here. The photo on the left is softer. It matches her smile better. The photo on the right, the light is more dramatic. So it might look better if she wasn't smiling so much, maybe. Because that would maybe match the mood of the photo more. Light, quality, softness is a big part in portrait photography, being aware of how that works. So that brings us to light modifiers, ways to shape and change light, to change the quality of the light, and there's 3 of them. The 3 are reflectors, diffusers, and flags. So a tiny bit about each. Reflectors take light and bounce it from one place to another. So oftentimes it's kind of like you play catch with the light. So you'll catch the light from one place and move it somewhere else. They're often used to fill in shadows. So if the sun is shining on one side of someone's face, you would put the other side would be in shadow. Let's say the left side's got sun, right side has shadow. So you would put a reflector on the right-hand side, catch that sun on the left, and bounce it back a little bit. It won't be as bright, but it'll fill in a little bit on the right-hand side then of that shadow side of the face. Reflectors often will have colors to match, either match or change the light source. So the common colors are white, which doesn't really change the color at all. Silver, which is very reflective, tends to add a little contrast to the reflection. And then gold, what that does is obviously it makes the light warmer. Be a little careful with that unless the light source is already warm like that. It tends to look a little fake. You can create your own reflectors with a piece of aluminum foil and some cardboard and some tape. Or that thing you have in your car that you put on your windshield on a hot summer day, that's also a reflector. A white piece of poster board or even a white sheet of paper will also be a reflector. Diffusers are our next category of light modifiers, and diffusers take light and spread it across a larger surface, which means now the light takes up less space. Takes up more space. So I'm sorry, I lost my train of thought. So the light is passing across a larger surface, so it fills up that surface, basically glows, so now the light is larger. This is used with flash, so that a small, maybe 2 or 3 inch light source can all of a sudden be 3 or 4 feet across, and therefore create those softer shadows, which are generally more pleasing on people's faces. Diffusers can be made... Just a white sheet will be a diffuser. That's a low-budget version of a diffuser. They come in all different shapes and sizes, diffusers do, but get the one you need, learn how to use it. We'll talk more about that in class as we go the rest of this quarter. And flags are anything that blocks light. They're generally black or dark colored and non-reflective, but it's anything that you put between the light and your subject so that you can shape and control what gets lit and what does not get the light. If you think about it, a baseball hat is a flag. The bill of the baseball cap is a flag. It blocks the light. So if you want a flag, you can make one with a black piece of poster board or anything that you hold up between the light and the subject that blocks the light from your subject. So those are the topics for your quiz. These slides here. If you have questions, please let me know before the quiz date. Glad to help you with that. Best of luck on the quiz. And remember, it's multiple choice, relatively low stress. The answers are already there. You just need to find them. Hope this review is helpful. Please let me know if you do have any questions. So until quiz day, see you then.